Ask any JavaScript developer to name three complex JavaScript topics. I am sure 90% of them will name promise in them. Yes, promise sounds like a very complex topic. It is complex only if you are not understanding it fundamentally. So, today, on day 23 of 40 days of JavaScript, we are going to get started with understanding promise. I can promise that this particular video is going to make a beginner to JavaScript or a beginner to promise, a professional to JavaScript, or a professional to promise. Why? Because once you understand the fundamentals of promises and how to work with it, I think you are going to open a different kind of door for you to do asynchronous programming in JavaScript and a lot of project development. This video is going to be lengthy, so I want to request you to take required breaks, required pause, and then continue going through the entire video. At the end of the video, you will also find tasks that are given, and my request will be to go through all these tasks, try to accomplish all these tasks, and if you are stuck anywhere, come to our Discord. Let's discuss. So let's see what are we going to cover today. First and foremost, we will learn what is promise, why do we need promise at all, and what kind of problem that promise solve for us. Then in the last video, we spoke about callback, isn't it? We learned about callback. So when we learned about callback, how and why we are coming to promises from callback. Then you have to understand the promise state, because without understanding the state of promise, you cannot really get into a lot of advanced topic. Then we learn about how promises are resolved and rejected, how promise can be composed with each other. That's one, promise composition. How can you handle promise? That is where handling the values, handling the error, handling the errors in multiple stages, handling the values in multiple stages, all this thing we'll learn. We'll learn about one of the beautiful concept called promise chaining. I think this is where the strength of the promise also comes in, where you can chain multiple promises together and make them work. We are going to see a lot of examples about that. We'll be handling multiple promises. Yes, multiple promises. There are promise APIs that you can actually take advantage of to handle them, and that's how you handle multiple asynchronous operations as well. Then we will talk about how to cancel a promise. Let me just take a note of it. And in the last video, you remember we developed a PizzaHub application using callback, and I told you that once we finish learning about promises, we are going to rewrite the same application using promise. Yes, we are going to do that. And finally, there is one more thing that I need to note down is task and assignments. You have to do the task and assignments. So this is what I promised to teach you today. Let's get started with the first one. What is a promise in JavaScript? You know why we find understanding promises really hard? Because we try to understand it more theoretical way. I think to understand promises, you have to relate it with your real life. So let's take some real life examples and then break it down our understanding to relate them with JavaScript promises. And let me know once you finish this section whether you understood promise correctly or not. So the diagram you're seeing on the screen is of a consumer, maybe a user, and there are some services. So as a consumer, you want to get some services, right? So for that purpose, you request for something from the service, and then once that particular service is available, it gets back to you in form of some response. Now this response can be a successful response that, hey, you asked for this service, you asked for this thing, and now, hey, this is a thing that you have got. Or it could be something error. You asked for something, very, very sorry that we are not able to give you that, right? The response can be anything. Now, what is promise? Promise, you can imagine like a placeholder for a value that may not be available to you immediately as a response. And again, when the value is available for you as a response, you get the proper notification of it. You have a mechanism to get whether you have a successful response or there is an error in the response. And then, not only that, based on what kind of response you are getting, you can now act on it. If you got a successful response, you'll be very happy, you'll be using the service. If you got an error, you might again go back to the service trying to understand, hey, why my service didn't come to me, what else I have to do, and again you might want to request it back, right? So if you have this picture in your mind, let's take some real life examples. Let's say you order a laptop from Amazon. So this is you and this is Amazon, which provide you the service of getting your laptop. Now they say that your order has been placed, expected delivery date in next 2 days. Now what is the situation you are in? You still don't have the laptop because laptop is coming in 2 days. So you don't have a laptop. So that means the laptop status is in pending. Now, once the laptop comes in 2 days, it may get fulfilled, means you have received the laptop, or it could also happen that on the way of that laptop coming to you, it get delayed or even it get lost. So it may get delayed or lost. So it means that whenever you were promised by Amazon saying that, hey, your laptop will be there in 2 days, the status of that particular promise was pending. Please remember this term I'm using, status is pending. Now, once you get back that particular laptop, it means that the promise is now fulfilled. That means the laptop is delivered. If you don't get that laptop, either it's got delayed or lost, that means there are some error over there, right? So this is one example of promise in real life. Let's take one more funny example, especially for the folks who are still bachelor, right? You have boyfriend or girlfriend or whatever, and then you have WhatsApp, and let's say you have sent a message to your partner, hey, how about a date tonight? Want to grab some coffee sometime? Now you see that there is a blue tick, right? WhatsApp, when you send someone, that person has received the message and read the message, so you got a blue tick, but you're still waiting for the response to come back, whether your partner has agreed to go out with you for a coffee or not. So this is your state of pending. Now once you get a message saying that, hey, let's go for a coffee, now that's got fulfilled. Or you may get a response if your luck is so bad, like, hey, I don't want to go for coffee with you. It's a reject, right? So in case of promise also, it's the same thing. The status can be pending, it can be fulfilled, or it can be rejected. We are going to get into the status very soon once you know how to start creating a promise. But right now, the conversation is about understanding promise in real life. If we understand the promise in real life, in JavaScript also, promise works exactly the same way. Another funny example, probably the last example of promise that I want to get you. This happened with me many times. Whenever I come out of a plane, and there will be an announcement like, if you want to find your luggage, you can find your luggage in the belt number 1. So I go near the belt number 1, the belt start moving, and I am watching every bag. Where is my bag? Where is my bag? That's the pending state. The moment I get my bag, grab it from there, it's fulfilled, but my bag is lost. I really don't know where my bag is. Now I have to go and find out. I have to do a complaint and find out like where exactly my bag. That's rejected, right? So there are different states, right, of a service. When you initiate the service, you are actually in the pending state. If the service is delivered to you, you are in the fulfilled state. If the service is not delivered to you, you are in the rejected state. So there are different states that we are already talking about that a promise can have. So to define promise, I would say in asynchronous programming, where you request for something and you really don't want to wait for that particular response to come, you want to move on. We understood from the last video that is what the asynchronous programming meaning. But what you want to have, you want to create a placeholder, like I have initiated this particular request, I am moving on, but how will I know if a request has been successful? How will I get notified? If a request has got an error, how will I get notified? I am going to collect my luggage on that belt, the belt is moving, my luggage is moving. In the meantime, I can go and grab a coffee. The luggage belt will still get moving with my bags or without my bags. I can go and grab a coffee. That's an asynchronous way of doing it. Once I come back, I might find my luggage over there. I can get my luggage and come out of the belt. That promise of getting my luggage on the belt is fulfilled now. Or it might happen that I came near the belt with the coffee. My coffee is over. Everybody got their luggage, but I'm still searching for my luggage. So my promise is not fulfilled. It got rejected. My promise of getting my luggage on the belt has got rejected. But I still have done some asynchronous work, isn't it? I went to the coffee vendor, got the coffee, and came back while my promise of getting the luggage was still happening. This is what the promise is in the programming as well. That's what we're going to see a plenty of examples, starting with the tiny one and then making it much, much bigger. I hope you like them. As you understand what is promise, and in the last video, we spoke about callback, isn't it? Callbacks are actually helpful. These are nothing but kind of regular function which can take another function as an argument. We have learned that. But a huge downside also, we learned that at times you may have callback inside another callback. Inside that callback, there is another callback. And what you end up with is a callback pyramid. We have seen that. Now that callback pyramid is not really good stuff for your debugging or the code readability. That's where when promise comes into picture, it actually solves that problem to a great extent. And when we are going towards the end of this session, we are going to see by taking a problem that we have created with callback in our last video, we are going to change that overall, refactor that overall using promises. But to understand that, we have to go through all the steps that we have right now. So let's understand how to create promise in JavaScript first, and then we'll be talking about the states of it. To create a promise in JavaScript, it gives you a constructor function called promise. If you are hearing the term constructor function for the first time in your life, I have created a video on object where I have explained constructor function in very much details, and we have also created custom constructor functions, custom objects. I think you must go through that video if you have any doubts about it. Promise is a constructor function given by JavaScript to us. Now, what exactly that constructor function takes? The constructor function takes a callback function as an argument. A callback function as an argument means it takes another function as an argument. Okay? And that particular function takes two more things as an argument. One is called resolve and another is called reject. So if you ask me what is most difficult thing in promise, I would say remembering this particular syntax. You have to remember this syntax, and once you remember this syntax, writing promises and creating promises will be really really easy for you. Rest of the things you don't have to remember, you will learn it eventually, but this syntax is something that you have to remember and you have to recollect. So let's take promise is a constructor function which take another function as an argument, and that particular function take two things as an argument. One is called resolve, another is called reject. We'll come to this function in a while, but before that, why there is a constructor function? Why constructor function even exists? Constructor function exists so that you can create different instances of that particular type. So here a constructor function promise exists in JavaScript so that you can create different type of promises based on your use case and need. Now, once you have a constructor function in JavaScript, to create different instances, you use a keyword called new. And here also, I'll be using a keyword called new. So once you do new promise, you are getting a new promise instance back. So that particular instance, now I can take inside a variable called promise or any name that you want to give. This is what a promise is for me. Now I can do anything with this promise. What I am going to do with this promise? Well, how am I going to get the fulfilled versus rejected or the resolved status? I'm going to get into that. But first, please acknowledge that you understand how to create a promise from the scratch. If you know this syntax, let's dive in. This particular function, I'm just going to take this function from here, Control C, I'm going to put it over here. This particular function has a name. It's called executor function. By the way, there are many things, many terms that I will be using here, or many things, many examples that I'll be showing here. I want you to take a note of it. I have already shared a progress tracker with you. If you have not downloaded the link of that progress tracker in the description of this video, please go ahead and download, where you can even take notes, because many of these things you will face in interview. Interviewers like promises. They like to ask questions from promises. So you need to really be ready with that. Okay. So this is called an executor function. The executor function takes two things as an argument. One is called resolve, another is called reject. What is resolve? What is reject? This resolve and reject both are functions given by JavaScript to us. Resolve and reject are the functions given by JavaScript to us. These are the callback functions that you will call inside the executor function depending on whether the promise has resolved or promise is rejected. So it means to deal with your promise, all the logic goes here. Now, before you write logic, there are few things that I want you to note, because there are some catch items or some corner cases people find a bit tricky. Usually inside executor function, you won't be calling both resolve and reject in the subsequent manner. You will be calling either resolve or reject. You might conditionally call resolve and reject, but you won't be calling like resolve, then reject, then again resolve. You will call either a resolve or a reject. Please remember that. This executor function is the one that handles the asynchronous operation. And after this asynchronous operation, because this particular function going inside this promise constructor, it returns a promise. This is the placeholder. And when you create this promise for the first time, the state of the promise will be pending. And once the promise is resolved, once the asynchronous operation has complete and it is successfully completed, you have resolved it, then the state of the promise will be changing from pending to fulfilled. Once it is getting rejected due to some error, maybe a network error, or you don't have access to a particular storage when you're making an input output operation, status of that particular promise could be rejected. So the promise can have three states. One is called pending, second is called fulfilled, and the third one is called rejected. Let's write a sentence about each of them. Like, what is pending? The promise will be in the pending state when the executor function start execution. What is the executor function? This is the executor function. Where do we place it? We place it inside the promise constructor. Please understand the things step by step. So once this particular function start executing, it means that it start making asynchronous call. That is the time this promise state will be pending. Then when it will be fulfilled? It will be fulfilled when promise is resolved. When it will be rejected? It will be rejected when promise is rejected. So please remember this state. These are very important and we are going to touch them again and again. Now along with state, there is one more thing that you have to keep in mind. That is called result. What is result? This promise has to give you something. Right? We took an example of Amazon. You have booked a laptop. So once the promise is successfully delivered or fulfilled, you will get the laptop in your hand. So that's the thing that promise should give you. If the laptop is lost, bad luck. So in that case, what you want to get? You want to get a sorry from Amazon, maybe, or they will reissue another laptop. Till you get the laptop, or the news of the laptop is getting delayed or lost, you are in the waiting stage, right? So still at the waiting stage also, there should be something that you are waiting on, right? So that's where the result is important, the value of the promises. So what are the different values that a promise can have? The promise can have these three different values. One is called undefined, then something called value, and then something called error. So how the state and value are related? When the promise is in the pending state initially, the value of the promise is undefined. When promise is successfully resolved, that time the value is the value that you got after the promise resolved. Okay. When there is a rejection, then the value will be error. Okay. So this much of theory is enough for us to start writing code, but it is very, very important for you to know that there is something called state, there is something called result. What are the state, and on those state, what are the values that you can expect from a promise? Now let's start writing things. Let us now learn how promises are resolved and rejected. We know the syntax how to create promise, so it makes sense now to get into the next stage of it. So let's create a promise. Let promise equals to new promise. It takes an executor function, and inside that you have two callback function. One is resolve, another is reject, that JavaScript gives us, and I'll finish this function. That's what is a promise. Now this resolve method I can call over here and say, hey, I am done. This is an example of a promise which will be resolved immediately. That means it will go to from the pending state to the fulfilled state immediately with a value called hey, I am done. If I create one more promise, let's say I call it promise 1, and let's copy this. Let's create one more, promise 2, and instead of resolve, if I call reject over here, and instead of saying hey, I am done, let's say something is not right here, this particular promise 2, will be rejected. That means it will go to which state? It will be going to rejected state with the value which is an error, right? So you now understand, right? When you have resolve, the value will be this. When you do reject, there will be an error. In that error, we'll have a message. The error message will be something is not right. Okay, so you understand what is resolve, what is reject. One important note, I told already that a promise executor should call only one resolve or a reject. Once one state is changed, means your initial state was pending, whether you go from pending to fulfilled or pending to rejected. Once the state change happen, that's all. any further calls to the resolve or the reject will be straightway be ignored. If you take an example of this particular promise, let another promise, a variable, new promise, and then you have the executor function. Inside executor function, I have first resolved this promise, saying that I am surely going to get resolved. Then I have rejected the promise. Then again I have resolved the promise. This particular rejection will be ignored. This particular resolve also will be ignored. If I handle this promise, I will be showing what is handling means. I will only see that this particular promise has got resolved only once. It never got rejected. It never got resolved one more time. Okay. But this is the thing that you have to remember. Sometime in interview, this kind of tricky question comes. They might give a program like this and ask you, hey, what will be the output of it? You should straight away say the output will be this particular promise resolved with the value call I am surely going to get resolved, and the state of the promise will be fulfilled. The reject and resolve over here is never going to get executed. So as we know now how to create promises, the next thing that we need to know is how to handle promises. Creation is fine. Creation is just about creating the order on Amazon that I need a laptop, but I need the laptop on my hand, isn't it? Or if there is a delay or there is something, I should know like something is happening. I need to know that notification. That's where the handling comes into picture. So let's know how to handle promises once you have created it. Coming back to our diagram, we have a consumer, or we have something called a service provider like Amazon, or we know a more technical name called executor, right? This is our executor function. Now we have a consumer, we have a service provider or executor. A promise uses an executor function to complete its task, right? And it completes the task asynchronously. I can come to the belt where my luggage or the bag is there. The airport authority or the provider of that service that I should get my luggage once I get down from the flight and go to the belt where my luggage is supposed to be there. This is the executor that is going to execute this job asynchronously. As a consumer, what I am looking for is the outcome of this execution. Either I should get the bag, or if my bag is lost, I should get some service through which I come to know that the bag is lost and what is the next thing. If I get the bag, then that means there is a success. So my promise get resolved. If I don't get the bag, that means my promise is rejected. But the bigger question over here, how do I know my promise has got rejected or is a successful? That is where there is something called handler methods come into picture. There are handler methods called then, catch, and finally. That helps to create the link between a service provider or executor to the consumer, so that when a promise get resolved, consumer come to know about it along with the value, in this case your bag. If the promise gets rejected, the consumer can still come to know with a value saying that, hey, your bag is lost, go to customer care, and if your luck is good, today you are going to get the bag. So let's see some of this in action with some code. So we are going to talk about then, we are going to talk about catch, we're going to talk about finally, and I want you to pay very special attention when we are discussing then, catch, and finally, because this is the heart of the promise. If you understand how then works, what are the different rules and the circumstances of then, catch, and finally, what are the different ways that you can use them, how to chain them, you learn everything about promises for sure. I would add a dot in front of each of this method, each of this handler method. Whenever I talk about then, catch, finally, I like to talk about them like dot then, dot catch, dot finally, so that when you use them, you never miss that dot. People face a lot of syntax error because they tend to miss that dot. So always use them with dot. Okay. So the first thing is like the dot then handler. Let's understand why dot then method exists and how it should be used. The dot then method should be called on the promise object to handle a result or an error. Usually in most of the tutorial or most of the places, you will see that dot then is used to handle a result of a resolved promise. But that's not true completely. Using dot then, you can also handle a rejected promise or an error. You know what? This is what is true. But most of the cases, you will be using dot then handler, promise handler, to handle the resolved result. Okay. It usually accepts two parameters. The first one for the resolved result. The second one is for the rejected error. So let's create a promise first. Const promise equals to new promise function. It takes resolve, comma, reject, One good thing that I have realized over the years working with JavaScript, you will really enjoy working with promises the more you write every character by yourself while programming in Promise. If you have to create promises multiple times, you're seeing I'm not copying from the, previous one, right? I'm just writing it because I want you to also do the same. As a result, the more you write executor function, the more you write constructor function, you will love promises more. Believe me, that's how it is. I have realized it myself. So now in this promise, let's resolve this promise immediately. I am resolved. You have resolved this promise. Great. Now at this stage, the promise state is pending. The value is undefined. Definition we have already learned over here, right? Now I have to handle this promise. Means once the promise get resolved, the consumer of the promise have to know that the promise get resolved. The executor of the promise over here might make a network call. So you can do something like over here, make a network call or an API call or an IO operation, whatever it is. And then once that is done, then you get a value and you say, I am resolving it. Now, a consumer who is actually looking for this particular promise to resolve, they have to take this promise instance of the object and they have to call something called then on top of it. This is the then dot then what I was talking about. Now this dot then can takes two argument. The first argument is a callback function. I'll quickly write an arrow function over here. And the second one is also another callback function. I will again write an arrow function over here. I'm doing it incrementally so that you never get lost. The first one expects a resolved result. The second one expects a rejected error. So if there is a resolved result, you can do anything with that result. Let me just do a console.log of result. If there is an error, let me do a console.error of error. Fair enough? In this case, this particular promise, I have resolved it. So that means when I'm handling this promise, what I'm expecting basically, I am expecting this to resolve over here. I am not expecting this error to be called because I have not rejected this promise. Isn't it? So that's why index.js line number 64, I am getting I am resolved. And line number 64 is which one? Line number 64 is this one. So that means my promise is now handled. And as I'm resolving this promise after a network call, API call, whatever it is, I am getting it over here with a proper resolving value. Now, instead of resolve, if I do a reject and I say I am rejected, what will happen? Of course, now this will be ignored because this promise was not resolved. Now the promise is rejected. It will be taking care of this error part. Now I'll see a console.error with this particular error message. Do you see that? I am rejected over here and it is coming from promise.then, line number 63, 65, which are nothing but these things. So you understood how promise.then works at a high level. Now here there are a few things. If you're interested only for the successful outcome, you can pass just one argument, means you can just ignore it. That means if you want your then handler to handle only resolve stuff, you can ignore the second argument. That is what most of the people do because there is another way of handling the rejected promise. We'll come to that very soon. But in some cases, your mind changes. You are a very different person and you want to handle only the rejection of a promise using then. In that case, if you don't want to handle the resolve promises, then you don't really need it, right? But if you just omit it, if you just delete it, JavaScript is now confused whether this is for resolve or this is for reject, right? Because you are removing the first parameter. In that case, instead of removing, you just pass a null. So if you do this, that means you are not at all interested in handling a resolve promise using the then handler. You are only interested in handling the erroneous rejected promise using .then. But as I told, in most of the cases, we'll be handling only the resolve promises using then because we have something called .catch using which we can now handle the rejected promise. So how does .catch works? Now the beauty of catch is as you have promise.then and you mostly be handling the resolve promise over here, you can now put a catch over here. It's like chaining it, and this catch take one argument, that is a function. So again, I'll write the arrow function for you and it handles an error. So I'll say console.error, console.error, error. Now, if I go and see the output, I'm resolved. See, promise.catch is no more coming from promise.then. It's coming from promise.catch, line number 66, 65. If I go over there, yeah, of course, line number 66 over here. So, what do we understand? If I am handling a promise, the promise can be resolved or it can be rejected, both. If I make it resolved over here, this catch is never going to get called because resolve promise by default will go to dot then handler. I'll now see from the dot then I am resolved is happening, line number 64, which is this one. And if I reject it, then it is going to catch because catch is now handling this one. So this is the dot then, this is dot catch. This is what you need to understand the role of them, individually, like where they are actually playing it. Now there is one more which is called finally. How do you do it? Finally, same syntax. It takes again a function, but it never bothers about either a resolved promise or a rejected promise. The finally will be called irrespective a promise is resolved or rejected. Usually, mostly you will be using finally for some cleanup process or maybe taking care of some loading indicator or things like that. Think about it that this is an asynchronous call, a network call that you're making, right? And maybe you have a variable called let loading equals to false. Now, once you start making this call over here, you would have done loading equals to true because using this particular variable, you might want to show a loading indicator on your screen. Now, what you can do, like irrespective of it is resolving, irrespective of there is an error, you don't want to show that loading indicator all the time, right? You want to kill that loading indicator. So maybe in finally, you will be doing loading equals to false, and that's the right way of handling it because irrespective of you get the value back, irrespective of your network call result into an error, you can kill that particular loading by making loading equals to false because you don't need this loading irrespective of whatever the outcome over here. So this is where finally will be useful. If the promise resolves in this case, then method will be called and then the finally will be called. If the promise reject in this case, then the catch will be called and then the finally will be called. I hope this is clear to you at a high level how then, catch and finally works. As we know, dot then, dot catch and dot finally, now let's learn about promise chaining. And here I am going to talk about a few rules. I want you to write those rules. I want you to practice those rules with examples because the successful learning of promise lies in using dot then, dot catch, dot finally in the promise chain. So let's get started with those rules. The first rule is very simple and we have seen it already. Every promise that you create in JavaScript give you a dot then handler method. Every promise gives you, because using dot then you can handle both resolve and the reject scenario. So dot then is a common handler every promise gives you, but every rejected promise gives you a dot catch handler. The resolve promise never gives you a dot catch handler. Even if you attach a dot catch handler on a promise and the promise is only resolving, not rejecting, the dot catch handler will be never be called because there is nothing to handle as an error. So only a rejected promise give you a dot catch handler. We have seen an example of this already. So I'm not writing a new example. Let's go to rule 2. And from here, things are going to be a little more complex. The rule 2 is about the usage of the dot then method. You can mainly do 3 important things inside the dot then method. Okay. You can return another promise for an asynchronous operation. You can return any synchronous value, or you can throw an error. These are the only 3 things that you can do inside the dot then handler method. And based on the situation, you will select what you want to do. Whether you want to return another promise, or you want to return just a value, or you want to throw an error. Let's take some example of each of those. The first example, return a promise from the dot then handler. Let us create a promise. I have created a promise. The executor function of that particular promise is basically returning an user information and the promise if the promise resolves. And that particular promise, I am holding it into a variable called getUser. So that means as getUser holds a promise, if I handle this promise using dot then, and as this promise is getting resolved, inside dot then, I will get this particular user value, right? Because I'm resolving with this value. The value or the result passing which you call the resolve, that particular value will be available inside the dot then handler. So I'll take get user now, and I can call dot then on top of it. It takes another function we know. So I wrote the arrow function. Like this, step by step you write, I think it will be very, very easy. If you don't want to write arrow function, for example, you can clearly write this particular function over here also, you know. But here, this function will get a value. What value it will get? Whatever the value I'm resolving with, that is the user. So I'll take a user over here. Now, if I do console.log got user.name, I will get John Doe. Let's see that. So I got user John Doe, line number 98. Line number 98, I got the user. That means my promise successfully resolved and I'm able to extract the value of it. Now from this then, as per our rule number 2, we can now return another promise from it. That's the example that we are interested in right now. So from this then, now I will be able to create another promise and can return. How can I create another promise? I can create like new promise. It takes a function takes resolve comma reject. I end this function. Here I can mimic an asynchronous call. For that, let's do a set timeout. In the last video itself, we have learned set timeout, which takes a function and then delay, after which this particular function will be executed. And over here, I will do a resolve, say Bangalore, and I have to return this promise. So now my this then method, this particular handler is returning a new promise, like making another asynchronous call. And after making this another asynchronous call, it found this particular user's address is Bangalore. And that is what it is resolved with. Now, how can I get this resolve value? How can I get the resolve value of this particular promise? This is where the chaining come into picture. If your then handler is returning a promise, you can now call another then on top of it, which takes a function, and you can get this resolve value that your previous then has returned from. So your previous then handler return a promise, it resolve a promise. That particular resolve value, if you want to get, you can chain another then, and over here you will get the return value, and you can say the user address is this particular address. Okay, so if I see this now, you will see got user John Doe, and after 2 seconds user address is Bangalore coming. Because this is the first resolve value, then I am making another asynchronous call to get the address. Once I'm getting the address, I have to handle that. I have to handle that means I have to get that value after that particular promise that has been returned from this dot then. For that, I will do a dot then over here. People make a mistake. They write this dot then here. No, you are not going to write this dot then over here because you are returning this promise. If you're returning this promise, you have to always make sure that you will write the dot then, chain the dot then on top of it. So first dot then over here is to get the first promise resolved. That is what the get user. This also a promise, we know. And then if this promise returning another promise, you have to write the dot then outside. Please remember this syntax. People make this mistake a lot. So this is one example where your then handler can return a promise, and how can you handle that promise further. Here, instead of set timeout, there could be a fetch call. The fetch call is to make an API call, or could be some IO operation. It can be anything, right? And then it can return another promise. You have to handle it in this way. Then the second case we spoke about is about return a simple value from the dot then handler. In this case, we're returning a promise. Now we'll be returning a simple value. So I'll take the same promise, get user. Let me copy till here. I'm doing get user dot then. I'm getting the user and then doing a console.log as usual before. Now from here, instead of returning another promise, I can return any value. I can say do user.email because user is having an attribute called email, right? Now I have returned this value from here. If I have to work on this value further, later point in time, I can do further dot then. Now this particular function will get an email, and I can do anything with this email. Console.log user email is email. Okay. So what are the cases you will be using it? Maybe after you get the value from this particular promise, you want to return this particular value so that later point in time, taking this value, you want to do further operation and then want to do something. So for example, the first promise gives you a database connection. Whether the database connection has been successfully established or not, you get a true or false that you pass. Now in the next then, you get that particular value, whether the database connection is true or false. Based on that, you want to make a subsequent call, maybe another call to get the list of users, another call to get the list of employees. That is the use case that I'm talking about. In this case, not necessarily you are returning another promise, you are returning a value. That value you can catch and can do something else. This also will give the output along with the previous one. So you can say user email is John Doe and this user address is Bangalore has come later because I have given a set timeout for 2 seconds, right? This and all got executed and then the set timeout output has come. Why and how in the callback video I have already explained. Now the third scenario, you can also throw an error from the dot then handler. That is also possible. And this is also very practical example. Again, I will take this get user itself, but now I'll be changing the get user little bit. Along with name, email and password, let me also add one more property called permission. Whether this particular user is having DB permission, HR permission, dev permission, engineering permission, what kind of permission? It has DB, HR and dev permissions. Okay. Fair enough. And then I have resolved this user so that I get this particular promise. Now taking this promise, my third use case where I can throw error from dot then handler. Let me demonstrate that. So get user dot then, what it takes a function, and inside this function I will get the resolve value. My resolve value is the user. By the way, another mistake that people make, what instead of passing this resolve value inside a function, this function is always the argument of the then, they directly pass this one over here and then they give a parenthesis over here. No, this is a wrong syntax. Your promise is never ever going to get resolved. So the right way of writing this is always write your promise dot then, and the then takes a function, whether an arrow function or you write a function like this, your choice. And then the function gets the value that your promise resolved. What your promise resolved, get user, what it is resolving, get user, resolving a user. So it will get a user. You will pass the user over. Simple. Just remember the syntax like this. Now let's produce an error. Let's say if my user permission includes HR and I will put a not in front of it. That means if you don't have a HR permission, then throw an error saying that you are not allowed to access the HR module. Fair enough. After this, you can return the user.email as is. Correct? Now, I have thrown a permission error saying that if the user don't have a permission call, HR, user.permission is an array. If the array doesn't have HR, in that case, you throw an error, you are not allowed to access HR module. Okay, what are the permission I have given? I have given HR permission, so I'll remove this HR permission. So this particular user doesn't have any HR permission. It has only DB and dev permission. That means for this user, whenever this permission change happen, I'm throwing an error. Now, if I throw an error from dot then, please listen to me carefully. Whenever I am throwing an error from dot then, to handle that, instead of dot then, you have to further do dot catch. If you are returning a particular value or returning another promise, for that you have to do dot then. We have seen this already. As I am returning an user.email, in case this particular error is not thrown, I am returning a value. To handle that, I have to have a dot then. And here I'll get an email inside the function. And I'll say console.log user email is this particular email. But I have a situation where I might also get an error because I'm throwing an error. I have to handle that using dot catch. Again, dot catch take a function just like before. I'm writing the syntax again and again so that you get familiar. Please code with me. It takes an error and here I can say error. So in this case, this particular user, I'm expecting that this error to happen because its permission doesn't include HR. So I'll get you are not allowed to access the HR module. And as this is happening, so it means that this particular return is never going to get called, is going to come out of this throwing an error from here itself. So this will never land into this dot then, rather it will go to this dot catch. Yeah, it says got user John Doe. And then there is an error, you are not allowed to access the HR module from line number 141, which is this. And you have seen that there is no output of user email. So it means that this then has not been executed at all. So these are the three different scenarios that a then can return a promise, it can return a value, or it can throw an error. you have to remember. That was our rule 2. We spent good amount of time in rule 2, and now it's time to go to rule 3. As you have seen that we can catch an error over here, right? Now rule 3 says that you can rethrow this particular error from catch. By the way, I have made a video on error and exception handling as part of 40 days of JavaScript. Make sure you go through it because everything is incremental in JavaScript, right? And that's how we connect the learning model or the mental model of JavaScript. If you don't know about throwing, rethrowing, creating new error, now you will be really stuck over here. You won't be able to focus on promises that I'm teaching you. So please don't skip any of the chapters before, even if it takes time. Complete the error handling so that these things are very usual to you. What is throwing, what is rethrowing, all these things. So when I'm saying that you can rethrow, it means that I got an error over here inside the catch. Now I can again throw it from here to handle the error later. In this case, the control will go to the next closest catch handler. This is the main point. Once you are rethrowing an error from a catch, there can be multiple other catch handler after that. The error will go to the closest nearest catch handler. Let's see an example of that. Let's create a promise. Let promise 404 equals to new promise. Again, executor function resolve reject, and over here we'll reject this promise. We'll say 401 maybe instead of not found. Let's say reject 401. So I have a promise. Now this particular promise is throwing an rejection. So it means I can actually handle it using dot catch. It is going to take a function, we all know, and this gets the error, the value that it is rejecting with. Now over here I can come and do it. First thing I can do, definitely console.log of error. I can always do this, simple. But let's say if it is a specific type of error, I want to rethrow this error from here so that I can handle it later point in time. For example, if my error is 401, in this case I want to do like console.log 401, and I can throw this error using the throw keyword, say this particular error I'm throwing. In the else case, you do some handling, right? Do something. Now, if this happens, and let's say after this catch, there is a then takes a function, and if it resolve a value, it takes that result, that value result, and let's say there is another catch, it takes a function, it takes an error, and it takes over this handling error here. This rethrowing will directly come to this catch. I have done a console.log of result also over here just to make sure that this then is never getting executed. So once this gets executed, of course this is promise.catch, it is rejecting, so catch will be called, this error will be handled. The error is 401, so we are rethrowing it. Now this rethrown error will never come into this. Then if I have another catch also, I can have 1 2 3 4 5 catches. How many catches doesn't matter, but the rule says the control will go to the next closest dot catch handler. So this particular catch handler is going to handle the rethrow. So if you see, I will now get handling 401 here. Okay, so let's see that handling 401 here. Okay, line number 162, line number 162. So this is my rule number 3. I hope you remember this, because in some cases you will do things like this, and that time you have to make sure that you're handling it in the right catch, because even if you have multiple catches after that, your control is not going to go over there. Rethrow is going to handle in the closest, the nearest catch. Let's go to rule number 4. The rule number 4 says, unlike the dot then and dot catch, the dot finally handler doesn't process the result value or error. We spoke about it, right? It just passes the result as it is to its next handler. So it means that dot then always try to handle the resolved value, the result. Dot catch always try to handle the error value. But dot finally's work is about cleaning up things. If you have initialized something, whether you have to garbage collect that, you have to assign it null, all this kind of cleanup procedure is what dot finally is going to do. But the best part of dot finally is it also gives the result or the error to the subsequent handler. It is coming after a dot then or dot catch. It just passes the result or the error respectively to the next dot then or the dot catch. Let's see an example. By the way, are you guys enjoying it? Are you guys liking the way that I am teaching promises to you? Is it something new to you? Are you enjoying? If so, please let me know. I would love to get your comment on this video, that if you are finding it really easy, like this video. And really, one request is to share about 40 days of JavaScript, the effort that I'm putting to create this quality content, giving it for absolutely free to all of you. Only one request is that share it with others, so that others also will come to know, channel also will grow, and they will also get something good to learn from. All right, so let promise finally, new promise function, resolve reject, resolve testing finally. Now let's do promise finally dot finally. Again, the same thing. What finally takes? A function. It takes a function, but it doesn't take any argument, neither a result or an error. So I'll say console.log of running finally. And then after this, you can do a then. What then takes? We all know it takes a function, it takes a result or a value, and you can do console.log of this result. What will be the output? This particular promise resolve with a value called testing finally. I am calling finally first. It doesn't take any value, result, or error. It will just execute whatever is given inside this function. So it will do a console.log. However, this resolved value is not getting lost. Even though finally is not taking any result or not returning anything from this, it is not losing this particular value. It will pass this as it is to its next handler. Next handler is what? Then. What then handles? It handles a resolve value. Did this promise resolved? Yes, this promise resolved. With what value this promise got resolved? The promise got resolved with these values. That means the result is over here. So if I run this, it will run a console.log of running finally, and then this particular result will be printed testing finally, because this is got resolved and then can handle the resolve. Let's see. So you got running finally and then testing finally, as expected. Now let's talk about the rule number 5, and one of the most important rule. What is the rule number 5? This is where I think interviewers ask a lot of questions, so please pay attention. The rule number 5 says calling the dot then handler method multiple times on a single promise is not chaining. What does it mean? Okay, let's see this. When you have a promise, you do a dot then on this, correct? Once this then returns something, whether it returns another promise, it returns another value, or it returns an error, you will again handle using dot then, or maybe using dot catch. Now if you see the notion of chain over here, you have a promise, on top of that you handle something, it returns something, the return value become an input to the next then again if it returns a value, if there is a then after that, it becomes an input to that then. If it throws an error, if there is a catch after that, that error becomes the input to that catch. How? If this promise resolve to a value, that value will come to this particular function as a result over here. Okay, result. Now if you do something inside it and after that you return something, so you do something inside it, do something, and say you return some value. Now this particular value will be now available as an input to the next then. So this value, will you can say again result or value, whatever you want. If you print the result over here, the value of it will be 101. Now from here, if you throw an error, this error will be available as an input to the next catch if there is a catch you are handling the error for. So this is what is called promise chain. Okay, this is what exactly called promise chain. You are calling the handler method one after another to chain them, so that output or the return value from one can be the input to the next one, so that they can be handled successively. But what people make a mistake is, instead of chaining, instead of calling the handler method on top of each other, they do things like this, and which is absolutely crazy. There is a promise, same promise, you did a then, again on the same promise you did then, again on the same promise you did catch. Is it same as the before, where we had promise and then we had chain the handler methods? Then we are now calling the then and the catch on the same promise instance. Look into this code over here and then look into this code. Are they same? No, they are not same. This is chain, because it's chaining the handler methods so that you can pass the value successively. Other one was no chain. That's why saying calling the dot then handler method multiple times on a single promise is not chaining. Can we take an example of this chaining? I have a promise, and this promise has an executor function. It resolved with a value called 10. Now I am calling on the same promise then handler method 3 times. But each time I'm calling the then handler method, it is doing different things. First time I'm calling the then handler method, the executor function, getting this particular value 10. It is incrementing and returning. Now here again promise.then is getting the value, it is adding another 10 and returning. Here it is getting the value and it is returning. So what will be printed on console.log over here at the line number 217? That's the question. Is it going to print the value 10, which I had initialized with, or it is going to return the value 41? 41 why? Because 10 got incremented over here, become 11. It returned 11. 11 comes here. 11 plus 10 is 21. 21 gets returned from here. 21 comes here. Plus 20 become 41 and 41 gets printed over here. So is it going to return 41? Or is it going to return 30? Because as the handler functions are not chained one after another, rather it is invoked on the same promise. They are not going to pass this particular value forward. As it is not going to pass this particular value forward, this value will be always 10, because this promise dot then whenever you do, it get the resolved value. So here it gets 10, here also it gets 10, here also it gets 10, and it gets 10 over here. 10 plus 20 is 30. What will be the output, whether it's 10, 41 or 30? The answer is the value will be 30. The value is 30. But why? Let's explain. When you call dot then or that or dot catch on the same promise again and again, you don't create a chain. As you don't create a chain, there is no question of passing the return value to the next handler, because every time you invoke a dot then on a promise, you are creating the new handler instance for that promise, and you are getting a fresh value, fresh resolve value from that promise. Every time you call a dot catch on a promise, you are instantiating a new dot catch handler method for the promise, and you get a fresh copy of the error that is rejected by that promise. Okay, so by this rule, whenever you're calling dot then, every time you get a fresh copy of this value that this particular promise has resolved with. So first time you get 10 because the promise resolved with 10. You got it 11, return value is 11. This work is done over here. This is never ever going to go to the next promise, because here again you are doing a dot then on the promise. A new instance is getting created. A fresh value of the promise resolve value will come, which is 10. 10 plus 10 is 20. You are returning 20. Again dot then you are doing, it is going to do the same thing, comes 10. 10 plus 20 is 30. So this is not a chain. Now to make it chain, you should not invoke it in the promise. Rather, you should chain all the handler method. So I'm now removing the promise, and rather I am chaining all the handler method. Now what will happen? Now the first dot then, the instantiation, first initialize happen. Fresh value of the resolve value 10 come here. 10 got incremented to by 1, become 11. Now it return 11. If we know that a promise then handler function return a value, it can return a promise, it can return a value, it can throw an error. We have seen that. If it returns a value, in that case you can handle the value by using another then after that, because this will be the value that we are returning from here. It will be the input to the next then. So 11 comes here. 11 plus 10 is 21. Again you are returning from here, so value become 21. This value become 21 here. 21 plus 20 is 41. It is going to print 41 over here. You are returning the value again here, but you don't have any other then, so that value won't be handled again. It just got lost, but you still printed 41 at the line number 217. So if you see, I have 41 at the line number 217. Great. So this is what you need to remember. Very, very important lesson. What is promise chain versus what is not a promise chain. So these 5 rules, write it somewhere. You are going to use it day in, day out with asynchronous programming in JavaScript, especially with promises. There will be situations when you have to handle multiple promises together. For example, you are making one network call to fetch certain information. You are making another network call to get certain things done. You may be making another network call to send an email. So there are 2-3 different things that you are doing, and everything is asynchronous. And for all these asynchronous operations, you get the promise back. So you have the promises with you. Now you have to handle those promises together, asynchronous operations, multiple asynchronous operations together. How are you going to do that? Are you going to run for loop? If you have 4, 5, 6 promises, are you going to run for loop on those promises and then do a dot then or dot catch on top of that? No, it's not at all an efficient way of handling promises, multiple promises. Rather, we should leverage the methods that JavaScript gives us, all the static methods that JavaScript gives us to handle promises, multiple promises asynchronously. So the methods that we're going to talk about are Promise.all, Promise.any, Promise.allSettled, Promise.race, Promise.resolve, Promise.reject. All the 6 methods that we're going to talk about. So let's learn about them, because this is what you're going to use practically actually in your application, because you will definitely have things like that. Your backend team will give you 3 APIs to get 3 different information. But boss, at the client side, you need some portion of the first API, some portion of the second API, some portion of the third API, some data from first API, some data from second API, some data of third API. Then you get all the data together and you want to show that into UI. How are you going to do? How are you going to handle those cases? That's where these static methods will be very useful. So now let us do the first one, which we call Promise.all. So Promise.all takes an array of promises as an input. So it takes an array of promises as an input, a collection, and it waits for all the promises to resolve, and it returns the array of promise results. So let us take 3 APIs. If you are a Pokemon fan, let me tell you that there are APIs to access the information of different kind of Pokemons. Okay, so I have 3 APIs. If you just access them on your browser, I copied one, go over here and let me just access. See, I get bunch of information about all the Pokemons, their ability, the slot. So now using this URL, I can make asynchronous call and get the data. So instead of getting the final data itself, let's assume that I have a method called getPromise. And if I pass any URL, for example, if I pass this particular URL, this gives me a promise as a return. So let me take that, let promise_1 over here. Okay, like that. For other URLs also, I got other promises, promise2, promise3. So for first one, I got promise1. For second one, I got promise2. From third one, I got promise3. Now you have all the 3 promises. Now, if you have to handle all these 3 promises, it doesn't make sense that you will iterate through using for loop or something. Again, using then and catch. You have a method called Promise.all. So you will do promise, the capital P, then all is the method name. And here you will be passing an array of promise_1, promise_2, promise_3. Now this will return a new promise to you. Okay, this will return a new promise to you. In that, you will find the resolved value of each of these promises. Now, if this return a new promise to you, to handle that, you need a then, isn't it? So you will do a then. It will give you the result, and then this result you can take and you can do console.log of result. So what would be this result? This result will be another array, and inside this array, there will be resolve value of promise1, resolve value of promise2, resolve value of promise3. Now, this might also fail. Right? So because of that, let me also add a catch. And here I'll be adding an error. And let me also do console.error of error. You're good? You're with me? Now, if I see the output, I will see an array of 3 elements, and each of the element are nothing but the result of each of the promises. You see all the results of the different Pokemons. First one, second one, and third one. Now, this is how the promise.all works. Now, a tiny change that I am interested in doing. For example, I will change any of this API. I'll from V2, I'm making it a V1. V1 probably doesn't exist. So this means this particular promise will fail. This particular promise will fail. Now, if any of the promises fail in the promise.all method, all other promises will be ignored. And as it is failing now, this won't be coming to dot then, it will come to dot catch and it will report this error. So if I go now, I see fail to fetch and get promise. You see this one? It is failing exactly. If I expand it, you can see this promise.catch is what reporting it. So you understand now very clearly like how Promise.all works. Now I'll be taking the same promises to provide you examples for Promise.any, Promise.allSettled, Promise.race, resolve and reject. But before I do that, I want to make you familiar with this method called getPromise. What exactly it is doing is very simple. Now, with your idea of promise, with your knowledge of promise so far, you will clearly understand what getPromise does. Let's go inside getPromise. I have a promise.js file. Inside that, I have written this getPromise, and this promise.js file I have already included into my index.html. So in index.js file, I can use the getPromise method. What is a getPromise method? It takes an URL, make a fetch call. In last video itself, callback video itself, we spoke about fetch a little bit. It's a JavaScript's own API through which you can make an asynchronous call on a particular URL. Now this one itself return me a promise. That's why I'm using this then. Now it making sense? In the previous video, I didn't explain to you. Now I'm explaining. The fetch itself return a promise. To handle that, I am now doing a dot then. Inside dot then, I am handling something. If the response is not okay, I can throw an error, because by rule we know inside then you can throw an error, you can return a value, right? Or you can return another promise. Now you are returning a value which is like response.json of method. The response.json itself return another promise. That is what you are returning from here. So that means the get promise is actually returning a promise. So whatever the URL you pass for that URL, before it returns the final result, it returns a promise. That promise you resolve to get the final result. So that particular promise itself I'm returning from here, so that I can utilize this get promise method inside my index.js file to demonstrate you that how to handle different promises. I hope it makes sense to you. Now, as we understand Promise.all, let us go ahead and understand Promise.any. Promise.any, it is similar to Promise.all method. Any also accepts the array of promises. So I can just copy from here and I'm pasting it over here. Just after all, I'm pasting this as any. It also accepts the array of promises, just like all, and execute all these promises in parallel. Okay. This method doesn't wait for all the promises to resolve. This is one of the major difference between all and any. All wait for all the promises to resolve so that it can return you an array of all the resolved values. The any method doesn't wait for all the promises to resolve. It is done when any of the promise is settled. That means if any of the promises is resolved, it is done. It return you the result. So it means that if promise 2 is first done, it will return the result of promise 2 and done. If promise 3 is done first, it will return the result of promise 3 and done. Same for promise 1. So that means the result that is going to return is never going to be an array. It is going to be the value of any of these promises. Make sense? So in this case, if I run now, it's going to return me one value. It's return me one value. One of the API's value, it returned whatever got executed or ended first. Now, after all and any, let's see one more thing which is called all settled. And this is something that I use a lot. Just like the all method, Promise.all settled promises takes an array of promises as an input. It waits for all promises to settle. Settling means fulfilling or rejection. Okay, please remember this. Settling a promise equals to fulfilling, which is nothing but resolve, plus rejecting. Okay, so whether it is fulfilled or whether it is rejected, it gives you the output of everything. This is why I like this method so much. In case of all, if one of them rejects, others are ignored. In case of all settled, even if one of them, two of them, three of them, even all of them gets rejected, you still get an output of the rejected promise. Let's see that. Let me just copy this guy and paste it over here. Instead of any, we'll say all settled. Now, Pokemon 1, Pokemon 2, Pokemon 3, all are running their correct URL. So, of course, it is going to give me this particular result. So, let's go ahead and see that. Yes, I got 3 output, but output is a bit different. For each of the output, now I'm getting a status and value. Status is saying fulfill. The status could be either fulfilled or rejected because it is showing me all settled. Settled equals to fulfilled plus rejected. So status is fulfilled. This is the value. Status is fulfilled, this is the value. Status is fulfilled, this is the value. Now it's time that I go back and for promise 3 this time maybe, I'll make from V2 to V1 so that this promise 3, the Kakuna one fails. Now if I go ahead and see the output, I expand, no error. But I see first two got fulfilled. Excellent. But the third one is rejected. Second one got the value also. Third one is rejected. As it got rejected, it won't get a value, but it will get a reason. The reason says that it's a type error failed to fetch, right? Because I have changed the URL in such a way that it's no more a valid URL, right? So that is the reason I love all settled, and I would advise that you use all settled as much as possible because you get a clear idea of why exactly certain things failed and your other things also gives the respective values, right? So this is about the all settled. Now let's move to the next one, which is race. As the name suggests, race means you are racing, right? So promise.race again takes an array of promises. It waits for the first or the quickest promise to settle, and then it returns the result or the error accordingly. So it will be like promise.race, you have again the array of promises, and then the result will be whatever the fastest, the quickest promise among them that got settled. And that's why you will be able to handle them using the then handler method over here. So in this case, we'll see the quickest one, the fastest one that got resolved and its data or its result. So these are the primary four methods, but apart from these primary four methods, there are other two static methods, which is like promise.resolve and then promise.reject. So basically promise.resolve, doing promise.resolve is same as doing this. You have new promise, you have the executor function, and you resolve it. Similarly, promise.reject, it will be as same as doing this. In this case, you reject. Okay. So these are the different utility methods that you should know. But the first four are the one that you'll be using more often in terms of handling multiple promises. Among them, you'll be using all settled most of the time in terms of handling multiple promises, multiple asynchronous functions. So I hope it makes sense to you. Now, another interview question for you: how to cancel a promise? In many interview, people ask for it, how to cancel a promise. And I'll give you the answer, but you will get much more in-depth technical answer in the video where I'll be explaining you the fetch API in the same module, same asynchronous module. We're going to learn about fetch APIs. That is where I'll be giving you much more in-depth technical answer. But right now, let me start with a theoretical answer. Let's say you have placed an order on Amazon. The order is to get a laptop, and you place the order. Amazon promises you to give the order. The promise got created. Right now, the laptop is not delivered to you, so that means the promise is not resolved. Neither the laptop is lost, so the promise is not rejected. The promise is in the pending state, and the value is like undefined. Now the promise has already been made between you and Amazon. Can you cancel that promise? You cannot really cancel that promise. What can you cancel? You can cancel that order. You can cancel that laptop. That means the value that you are expecting that promise to return, you can cancel that. Exactly the same thing in JavaScript promises. Promise cannot be cancelled. If someone is saying promise can be cancelled, no, promise cannot be cancelled. It is the process which return the promise that can be cancelled. In our example, the process of giving you a laptop, that is an order, that can be cancelled. But whatever the promise was made initially when you place the order, that cannot be cancelled because that is past. Correct? So if I draw the same analogy to technical aspects in JavaScript, when you make a fetch call to get an API response, or an XML HTTP call to get an API response, or maybe an IO call, right? These things are cancelable. You can cancel them. You can cancel an XML HTTP request. You can cancel a fetch call because XML HTTP request has an abort method. The fetch call having the abort controller signal, these are all cancelable. But promise that you have created, that is a result that you cannot cancel. But the process, which is like fetch, XML HTTP request, all this thing you can cancel. So this is the answer. Like, can you cancel a promise? This is the answer. Now, how can you cancel the promise? You cannot cancel the promise. You can cancel the process through which you were returning the promise. Means you will be able to cancel the fetch call. using something called abort controller and the signal. That is what we're going to learn when we are learning the fetch API in the upcoming video. That is where, along with getting inside fetch, I'm also going to teach you what is signal, what is an abort controller, why and when you should be using abort controller, and that's the answer of the portion that you can cancel while dealing with a promise. So I hope the answer is clear, the technicality of it coming in the next video. So folks, do you remember this code? Order pizza? I'm sure you do. If you're coming from the last video where we discussed about callback pyramid and all these things, we built this application for ordering pizza. We created our own API, and then we have collected the information about a PizzaHub store, then the pizza available on that store, and then the add-on beverages for that particular pizza, and then we went ahead and placed an order, and then we printed the confirmation of the order. We have done a lot of stuff, and while doing that we got into something called a callback pyramid. I mean, a callback under callback under callback under callback, like that. Now what we have decided is, like, we're going to simplify this one with promises. Let's see this particular code that is already there with you on GitHub, part of day 22. Now in part of day 23, I'm going to write the promise version of it. Let's start doing that. So coming to day 23, let me create a new folder called Pizza Hub. Inside Pizza Hub, I'll create two files, one called ph.html and then another one called ph.js. ph.html is the exact copy of index.html file from day 22, the one that we have seen last time. Exact copy. It was depending on index.js. Now it is depending on ph.js, where we'll be writing the logic with promises. And it was using a query.js. If you remember, using a fetch call, it will still use a query.js under lib. So I'll be creating a new folder called lib over here, and let's call a new file called query.js. And here I'm going to write the definition of query a little bit differently. It will still use the fetch call like before, but right now my intention is the query will return a promise. And as it return a promise, I will be able to handle the promise in my ph.js file for each of the endpoint of the API call and make the entire code much more simplified. Okay. So my version of the query method which returns a promise is like this. And I'm going to explain this to you what it does. The query takes an endpoint and an options like before. It used to take an endpoint and options. Right now also endpoint and options. It returns a promise because I want query to return a promise so that I can resolve this promise. So taking the endpoint, it makes a fetch call, and the entire fetch call, if you see, is inside a set timeout. That means every fetch call will be delayed by 2 seconds so that I can simulate a delay, because all my APIs are locally available. It will be going very fast. You have seen in the callback video already. There also we had given some kind of delay. Here also I'm giving a delay for executing the fetch call. I'm giving a 2 seconds delay. Now once the fetch call has been made, the first then will give me the response. I'm checking if the response is okay. If it is not okay, I'm throwing an error. Otherwise, I'm returning a response.json, which itself return a promise. Now, ultimately, if I'm calling this query method using an endpoint, I'll be receiving a promise. If I resolve that promise, then I'll get the actual JSON representation of that particular response. If there is an error, then of course there is a catch. So this should work. This particular query should work. Now let's go to ph.js file where we'll be writing our logic. Let's go bottom up. Let's do order pizza, veg, and margarita. So first thing first, we have to do a function order pizza, which takes a type and of course take the name of the pizza. Now we will be writing the logic just like how we speak in English. First we have to get the shop IDs. So let's assume we'll have a method called get shop IDs. Now get shop IDs method will return us a promise. That promise, if I resolve, I will get the bunch of shop IDs as a result. So inside then I can take a function, and this function will get all the shop IDs that this will return. Now, if I get the shop IDs, taking the shop IDs, what is the next step? Once I get the shop ID, a bunch of shop ID of the Pizza Hut, Domino's, or whatever it is, I can pick up the first shop that is available right now and try to get what are the different pizzas available over there, right? So for that, let's imagine that I have another method called get pizza list, and over here I can pass the shop IDs first shop. Now this get pizza list is going to return me the list of pizzas available in the shop, isn't it? So it means that on top of that, now I can do again a then, which will get a function as an argument, and this will get all the pizzas over here, right? Pizzas over here. And for now, let me do a console.log of all these pizzas. Let's see till here things working or not. Okay, then we will proceed with from the pizzas. We'll get my pizza with add-on, and then we'll place an order and everything. So the first thing that I want to do is the implementation of get shop IDs. Let's do that. So first function get shop IDs. The URL to get the shop ID is /API/PizzaHub. Taking this URL, I can just call the query method from my query.js, passing the endpoint. Options is an optional argument, for the post method only it uses. Ours is get method for now. So I'm querying this. Now this returns a promise, right? Query returns a promise. This particular promise I'm resolving now over here using then, and this will give me all the shop IDs as an array. From there, I'm picking up the first shop ID, and I'm having a method called get pizza list. Now let's write the get pizza list function. Function get pizza list, and it will take a shop ID. Again, if you have missed the previous video of callback, you probably will find some missing links because I'm not explaining all these APIs and everything. Again, I would request you to look into the callback video where I have executed each of these APIs using Postman. I have showed how I have created this API so that it makes sense to you. Otherwise, you can ignore this particular section if you are not keen to learn from the callback. So far, whatever I have taught you about promises, that's all, okay, for this video. But if you really want to know how I am solving a callback problem to promises, I would really strongly request you to go through the callback video, go through the PizzaHub project that we have done together, and then come back here so that you understand how we are solving this problem. Now I have the shop ID. The URL to get all the pizzas in the shop ID is this API/PizzaHub/pizzas, then the shop ID. And then again, passing this particular URL, I will do a query. Now this URL again will go to query.js. It will return a new promise. The promise comes here, and once we resolve this promise, it will give me all these pizzas. That is what I am printing over here. Okay, so now if I go to ph.html file, I would expect this will get resolved, and I'll get the pizzas listed. This far it should work. Uncaught syntax error. Okay, I got it. Okay, this is function spelling mistake. Okay, now if I go back, now if you see this network call, the first network call happened, it gives me Pizza Hut, the shop ID. The network call happened, and it gives me the response, which is the pizza available, the array of pizzas available in that particular shop. This is the second one. Slash, if you see that, localhost 3000 API Pizza Hub /pizzas/ Pizza Hut is the shop ID. The previous one was Pizza Hub, right? So both the calls are happening and giving me response. So it means I can now proceed, right? I got all the pizzas. This is an array of pizzas. Now, after getting the pizzas, what is the next thing that I'm going to do? The next thing that I am interested is to get my pizza, the pizza that I have ordered it. So I have got a bunch of pizzas, right, from the shop. I want to check whether my veg margarita pizza is available. And along with that, what is the add-on that I can get? What is the beverage or the drink that I can get, right? So for that, now I will create a function called get my pizza with add-on. In that, the pizzas is an array, right? So I'll pass the pizzas array, and then the pizza, my pizza that I'm looking for, and the name of the pizza I will pass on, right? So let's implement this guy, get pizza with add-ons. So function get pizza with add-on. The parameters are pizzas type and name. And just like we have done before, we will see whether I have a pizza like that with this type and name among all the pizzas. So if I find, I call it as my pizza. Once I get my pizza, then I will try to figure out whether I have any beverages or the add-on or not. So I will make an API call to /API Pizza Hub beverages, this particular pizza, my pizza's ID, and then as usual, return query and then pass the URL, right? This will return a promise. And this guy now I have to handle using then again. So if I handle using then, now I'll get here pizza with add-ons, correct? After getting pizza with add-ons, the next thing that I will be doing is to perform the order or place the order, whatever. Perform order. What are the things I need for performing order? Whatever the add-ons I got, I know that it will be an array. I have seen in the last video. So I will pass the first element of that particular array in the perform order. So now in the perform order, my next API call will be there. Say function perform order result. Here, what I'll be returning? I'll be returning again the query, and my URL is slash API slash order, and I have to pass an option because it's a post call. The post call option will be method post, and I'm passing the pizza ID and the beverage ID as my payload. Now this post call will be successful. After that, my order will be placed. Now if the order is placed, what it will return me? It will return me the time when the order has been created. So basically it will return me an order info, and then taking this order info, now I can either do a console.log or I can even write it to another method, say confirm order, and I can pass the type of my pizza, the name of the pizza, and at what point in time this particular order has been created. That's it. This is all my then. And to be safe side, I'll also have a catch where I can say if it is error, console.log of error. Now the confirm order, let me create a function for confirm order with the type, name, and created at. I'm saying console.log your order, this particular type, name has been placed at this particular time. That's it. All right, so let's see the code once more. I have the order pizza function. In the order pizza function, I'm taking the type of the pizza and the name of the pizza. I first get a get shop IDs method, which return a promise. I resolve the promise, get the shop IDs. From there, I get the first shop ID. Pass to another method called get pizza list, which also return another promise. So I have another then over here, and then it gives me the pizzas. That pizza I can pass to my next call, which is like get pizza with the add-on. It returns me pizza with the add-on information. So once that promise get resolved, I get this. Then with that, I can actually perform an order. Once this get resolved, I get the order information. Using that, I just print a confirmation of order. If there is an error, then the catch will handle that particular error. And all these methods are created at the top one by one. Isn't this code much, much cleaner than the code that we have seen before with callback, where we had lot of dependency of one callback to another callback? It had created like a callback pyramid. But in this case, as you see very, very clearly, that the code is much, much simpler. Can you see the output? So first, PizzaHub. Okay, Pizza Hut. Then number two is the beverage, then the order that comes in the order. And first, finally, we'll have your order of which margarita has been placed on this particular time. So as you see, all these calls are happening with delay, but all these calls are taking place. Just like the previous video where we had printed each of this output on the UI, right? First, located the store, then placing the order. If you want to do that, you are most welcome to do that. In fact, I would suggest that you try that so that you change this code. This code is already with you. I'm going to show where you can find this code. So this code is already with you. You can modify this code because you have ph.html file, you have this div and all h1 p everything is there. You can do document.get element by id and fetch the store, order details, add on everything in your ph.js file. And after that, you know how to add the text content and you add those messages. So again, if you're coming from the previous video, you can very well follow that and do that task yourself. Apart from that, one more request would be, please do the task that I have provided. I have provided, I think, 10 plus tasks in this video using promises or whatever I have taught you, whatever you learn out of this video. Please complete those tasks because that's going to solidify all your learning. Requesting all of you to come to github.com/tapaScript, follow this page because apart from 40 days of JavaScript, you get to see many other repositories that might be useful to you. But at this point of time, if you come to 40 days of JavaScript repository, over here, you can find day-wise breakup of the code. We are on day 23. You will find a day 23 once this video is published. Inside that, you will be able to find all the code and the task.md file where your tasks are there. Request you to start this repository if you like my work. That's a great motivation to get from you. So friends, again, a long video, I understand, but it was required. If you are here from the beginning, I want you to comment again on this video saying that I have achieved it and If you learn promises, please let me know that you have learned promises. As a whole, you will be able to use it. Up next, we will be taking the promises forward to understand async await keyword, the newer introduction to JavaScript, and that makes code much simpler. We'll be also debugging the async await code to understand things a little bit more deeper. After that, we'll be doing another video with the fetch API. I want to get into the details of fetch API, and then the last video of the asynchronous module will be about learning event loop. Okay, with all these things that we are learning. So everything that we have done so far, very useful, very important for your career. I hope you like it. Keep learning. Stay with tapaScript. We'll be coming back again soon.